Hey guys, so I'm gonna keep these videos even shorter because I'm having trouble uploading. These two worksheets were due Tuesday, I want to say. Let's see here. Yeah, so real quick, I'm gonna go through them real fast. So this one here. All right, polarity, what kind of solvent, solute? Solvent would be water, which is polar. Solute, ionic. So that would be the interaction. Ionic and polar. Polar is partial negative, partial positive, surrounding the positive cation, negative anion of Na plus Cl minus. So dipole, ion-dipole interaction. Solvent is water, solute NaCl. Particles that compose sodium chloride crystal. This crystal is made of Na plus ions and Cl minus ions attracted with an electrostatic interaction called an ionic bond. What happens to the attraction between dissolved hydrated ions and the remaining solid crystal? So these hydrated ions, Cl minus, can you see this? Yeah. Cl minus and Na plus, they are surrounded by the water, and the attraction that this Na plus has for the crystal and this Cl minus has for the crystal is weakened, temporarily broken, because now it's more attracted to water. What is separation of ions called? This is called dissociation. I'm going to write that word down. Dissociation. That's an important word. Dissociation. Let's use rainbows here. I'm hearing people are putting rainbows in their windows and stuff for hope and solidarity right now. So let's use rainbows. So when you have NaCl dissociating in water to Na plus and Cl minus, AQ, that's called dissociation. So when you put, that's an N. When you put salt in water, it dissolves, but dissociation is what it's called specifically when ionic compounds dissociate, break apart into their ions. Okay. What's separated? Part of water, we've done this a million times here. You know what? I'm just going to answer this out loud. Water, the oxygen is the big one here, facing the Na plus. Hydrogens are facing away because oxygen is partially negative. Here, partial positive hydrogens are attracted to Cl minus, so hydrogens are facing the Cl minus, opposites attract, oxygen's the other way. I've done this a couple times with you. We've talked about it a few times, so moving on. Okay, this one. All right, let's see. What is being plotted on the X and Y axis? X is temperature, Y is solubility, meaning how much you can dissolve at a certain temperature in a certain amount of water. What does this illustrate? As temperature increases, the solubility goes up. What does that mean? It means you can add more of the same chemical. Let me rephrase that. You can add more of that chemical to the water. Let me start over again. Holy cow. Increasing solubility means you can dissolve more of it. Increase the number of grams that you can dissolve in the exact same amount of water, right? That's what this means. So as solubility goes up means you can dissolve more of it in the same amount of water. Why? Temperature is going up. Temperature increase means water has more energy to break down more particles. What is the solubility of each at 0? NaClO3 is about 79. KBr 59. KNO3 17. NaCl 32 grams. All right, which is most soluble and least soluble at 80? At 80, most soluble, 80 degrees would be NaClO3. You can dissolve the most of that, about 190 grams. The least would be salt, right around 40 grams. What temperature do KBr and KNO3 have the same solubility, and what is that? KBr and KNO3 have the same solubility at around 49 degrees Celsius, 49 degrees, and that is 80 grams. That's the solubility of both of them, 80 grams in 100 grams of water at 49 degrees Celsius. What temperature does NaClO3 have a solubility of 180? 180 NaClO3, the temperature would be about 73. What's the general statement you can make soluble NaCl compared with the other three? So NaCl solubility does not vary or does not increase as much, whereas the other three, their solubility increases dramatically as temperature goes up. NaCl is not as affected by, the solubility of NaCl is not as affected by temperature as the other three. All right, so that's that.